project, I'm doing projectile motion. And my question is, an object is launched upwards at 96 feet per second from a platform 110 feet high. What will be the object's maximum height? When will it reach this height? So in order to solve this problem, you need to use the formula st equals negative dt squared plus v subscript 0t plus h subscript 0. Now, what do these variables mean? Well, negative g stands for the value of gravity, v subscript 0 stands for the initial velocity, and h subscript 0 stands for the initial height. So let's go over what the variables in this equation mean. Negative gt stands for the value of gravity, which in this case is negative 16 feet since this equation is in feet. And v subscript 0 stands for the initial velocity, while h subscript 0 stands for the initial height. So when we're plugging in the values into the equation, we get negative 16t squared plus 96t plus 110. Now the only way to solve for this equation by hand to find the maximum height would be by using the vertex formula, which is h equals negative v over 2a, in order to find the x value. So when we plug that in, we get negative 16t squared plus 96t plus 110, and then you get h equals negative b over 2a. Since this is a, b, and c, negative b would be negative 96 over 2 times negative 16, which is a, which turns out to become 3. So now in order to find the output, you need to plug in 3 back into this function, and then you get negative 16 times 3 squared plus 96 multiplied by 3 plus 110, and that becomes 54. So the vertex is 3, 254. The maximum height is 254 feet, and it takes 3 seconds to reach this height. So our second method would be by graphing. And so we're going to use a graphing calculator. And as you can see over here, we have negative 16x squared plus 96x plus 110 plugged into the y1 equation. And when you graph it, you can see that the graph is facing downwards since it's negative 16x and not positive 16. So in order to do this, we have to find the maximum value since the parabola is facing downwards. So we place 2 spots and then we press enter. And as you can see, we get about really close to 3 and 254 as our vertex. So the maximum height is 254 feet, and it takes 3 seconds to reach it. In the third method, we can use a data table. And as you can see here, all these data points that belong to the parabola cannot be negative because we're dealing with the real world problem and we have to have a positive value. So since these are all negative values and these are positive and there's negative here, we have to take the positive values in between and see which one has the greatest value, y value. As you can see here, the greatest value for y is in 254, and that is 3 seconds, which means that the maximum height is 254 feet and takes 3 seconds to reach it. So the vertex in this case is 254, which is the same as when we were graphing and the same as when we were using the formula by hand.